Okay, so we rifled through the first couple parts of 9.2, trying to highlight the point that there is a massive amount of variety in organic molecules. So what we're going to have to do is come up with a very specific set of rules on how to name, draw, and describe them. All right, candle wax or pentacosane C25H52 with its over 36 million isomers is going to be a hard thing to organize and classify if I don't come up with a very specific set of naming rules. So the purpose of the previous two videos was to really try and hit that point home that we are going to need a very specific and a very inflexible set of rules in order to be able to categorize such a large and varied group of chemical compounds. So the rules for alkanes, our most simple type, all right, are single bonded carbon molecules, just like all the rest, are going to follow a three-part naming rule. Okay, the first part is the root. And the root is going to be the longest continuous chain of carbon-to-carbon atoms. This can be a zigzag line, this can be a ring structure, this can follow a path all over the page, but you're going to be looking for the longest continuous chain. For Chemistry 20, we will likely limit these to a maximum of 10 carbons. Okay? Counting to 10, when we take a look at it, uses the Latin prefixes here to describe the number of carbons. This is a table that you will want to memorize. Meth is the prefix for 1 carbon. Yes, that meth. Eth is 2 carbons. Prop is 3 carbons. Bute would be a 4-carbon chain, and the rest you recognize as they get similar to the Greek prefixes of pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and dec for 10. Okay, those are the prefixes. In this case, since we're dealing with the alkanes, you can see they all have the same suffix, which we'll talk about next. And so your suffix is to describe how the carbon-to-carbon atoms are bonded in this longest continuous chain. For things that are only single bonds, we use the suffix ane. And so remember, to be a saturated alkane, you have to have minimum bonding between carbons, hence single bonds, and therefore that allows for a maximum of hydrogens to be stuffed in there. So the suffix of ane for propane or ethane or pentane actually means a lot to me. The last thing we have to talk about here is the potential for any sort of branches or add-ons to this chain. And this will start to set a list of prefixes for us. In Chapter 9, these branches and prefixes will just be other carbon-hydrogen attachments. And so we like to think of them as branches off of the parent or root chain. And they get the same meth, eth, prop, bute, and pent kind of idea. But to denote them as different from the longest continuous chain, they do get a different suffix or suffix on the branch name. Sorry for that, but yeah, we call these alkyl branches. All right, and they get this little YL as part of their name to denote them differently. So let's take a look at an example of one, because I know it just comes across as gibberish right now. And here we have a molecule given to us here. Okay, you can see that all sorts of stuff is going on. I've got a hybrid here between the line angle formula and the condensed structural formula. All right, that is another one that is not explicitly given to us in our text, but most of our organic molecule generators, if you will do this for us. So you'll also see that, but we probably won't ask you to draw it that way too often. The first thing we need to do is identify and name the root, which is the longest continuous unbroken chain of carbons. So it's kind of like one of those old Mensa puzzles where you have to draw these various lines, but they're not allowed to cross over each other. So what we would do is we look for the longest continuous line that I can draw between carbons. Just for your help, there is one here, and there is one here. So here's 1, 2, 3. Okay. Here's 1, 2, 3, 4. Here's 1, 2, 3, 4. Here's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. You can see that there are lots of possibilities for a 3-carbon and a 4-carbon chain. Since we had many different 4-carbon chains, all of them are valid. In other words, if you identify more than one longest continuous chain, chances are they are both valid. So this one here is actually identical to this one here. Now this does have connections. If we had a molecular model kit, I would show you why they're the same with a tetrahedron and all that. But ultimately, while it might look visually different on the page, please understand that they are the same in their 3-dimensional shapes that we might recall from the bonding unit in Chapter 3. So I'm just going to, for poops and giggles here, identify this as my longest continuous carbon chain. So 1, 2, 3, 4 carbons. What we want to do now is go back to our table up here and find the prefix for 4 carbons. There's 4 carbons. Its prefix is bute. So we know that this is a bute molecule. We need to go now identify and name the suffix. For this, what we're looking at is how these things are bonded. Since we're at just the beginning steps and only dealing with alkanes, this will be pretty easy. As we go further through the unit, there'll be more to look at. But you can see that they are all single bonded, and so single bonded carbons are known as alkanes, and so we get the suffix ane for this one. So now we know that this is a butane molecule. Lastly, we have 2 offshoots, one here and one here. In other words, we have 2 branches on this molecule. To name and appropriately list branches for our molecules, there are a couple of sub-rules to follow here. The first is number the carbons so that the prefixes have the lowest possible number when we go through it. That means you're going to look at it forwards and backwards and try to make sure that you have the lowest possible numbers. If this is carbon 1 right here, then I have a branch at carbon 2, a branch at carbon 3, and there's carbon 4. That was looking at it from bottom to top. If we look at it from top to bottom, it is possible with some molecules we get a different numbering strategy. Here's carbon 1, a branch at carbon 2, a branch at carbon 3, and then there's carbon 4. So what we found is it doesn't matter which way we number this, from bottom or to top, we get the same 2 attachments. So the lowest numbering strategy here is 2, 3. We don't have it in this case here, or so we do. We will use Greek numberings, di, tri, tetra, penta, with the prefix if there is more of one of the same kind of alkyl group. Now, this will come across as redundant, but it is still part of the official naming rules. So we have 2 1-carbon chains, which means we have 2 of the same branch attachments. So we will have to use the prefix di. And then if we have a large variety, we list all these prefixes in alphabetical order. So what is the final name for this guy right here? Well, we had said that we have, okay, where should I write this? We have bute for the longest continuous chain. We have ane for how they are bonded, for our suffix. And then we have 2, 3, di, because we have 2 of them, 1-carbon attachments. For your alkyl groups, they are here. A 1-carbon attachment is known as a methyl group. And so the official name of this one is 2, 3 dimethyl butane. All right, big long name, but we're also trying to come up with a naming strategy that can handle things such as 36 million isomers. So yeah, they don't roll off the tongue all that well because there's a lot to do with them. But after a few practices with this, I think you'll start to figure out what's going on. So in the next video, we will go through these examples. You can see I have condensed structural, empirical, and line angle examples on the page here. We'll take some time and we'll go through them all, and we will identify it in that 3-step cadence.